can handhold a telescope, it requires some sort of a mount. Generally, there are two types of mount. One that moves in altitude and azimuth, that means up and down, and also around. So azimuth will be around, altitude will be up and down, and this is called an alt-azimuth telescope. So an alt-azimuth telescope is just like a tripod. You can move the tripod up and down and left and right. In astronomy, the equatorial mount has been used for more than 300 years, and it's a very clever way of using this alt-azimuth mount in a tilted manner, where your tilt is the same as the latitude of the observer. We tilt one of the axes of the motion, and we call this the polar axis of a telescope. The telescope rotates on this polar axis at the same speed, but in the opposite direction of the Earth's axis. So if the Earth rotates this way, the telescope will rotate this way. And normally, this motion is achieved by using a motor around this shaft here. So as the night goes on, the Earth rotates. Our telescope will rotate in the opposite direction of the Earth, but with the same speed as the Earth. Now, the axis that we call the polar axis has to be tilted towards either the north celestial pole or the south celestial pole. If you look at this equatorial mount on Earth, we see that this axis is our polar axis. This is pointing at north celestial pole. So is the Earth's axis. It is also pointing at north celestial pole. As the Earth rotates this way, our telescope rotates in the opposite direction with the same speed as the Earth. We point our telescope tube in any direction we please, as long as it all rotates around this axis of motion, just like the Earth's, except in the opposite direction. As we can see here, all night long we can move the telescope around this axis that's pointing at north celestial pole. The telescope tube itself can be pointed in any direction whatsoever, but it always moves on the polar axis. So it follows the objects in the sky all night long.